So this is another example of Miller-Bravais indices for the hexagonal closed-pack system, and we can see that the direction in this case it's starting from this corner and goes all the way to the top surface on the center of that hexagon. So, and sometimes in this case you can see that the origin is not in the, the tail of the vector, the direction is not in the origin, so that complicates a little bit our work because we have to work with multiple with the tail and the head and the subtract, and it will add more work to us. So one thing that we do as we discuss in the class, because this is a direction and there are an infinity number of directions that are parallel to the same one that we are talking about here. That helps us to just shift this, move this vector in a parallel way, so that this tail it's right here in the origin of the coordinate frame. If we don't want to move the vector, we can move the coordinate frame if we want to and put it there, and it will still be in the same family of the vector, the directions that we are trying to find the Miller-Bravais indices. So it's much easier for me to move the vector right here, and as we can see that as we move with 1 unit right there, the top also moves with 1 unit right there in this way. So again, we get in that situation we get basically to work with this 3 coordinate frame, 3 coordinate axes like A1, A2, and Z, and ignore for a while initially the A3, and then we convert, like we mentioned here, from the 3 axis frame to 4 axis frame. We use the same principle as in the previous video. So here you can see that we try to find, after we moved there, we can see that when we get the projection of that vector down here, we will end up with having a vector that is starting from this point. That is going to be the projection right there. And now, as we did in the previous one, we try to get to find the coordinate for this point right here from the tip. There we are taking a line that is parallel with A2, and when we drop it here, and we can see that it's exactly 1A. Which 1A is the side of the equilateral hexagon. So if we are dividing by A, in that case we get 1A divided by A will be A1. And then again we do the same thing, we take a parallel to this A1 and we drop that tip all the way to A2, and we obtain the same 1A here, which divided by A will be A1. Another fraction, an integer. And when we look at the same projection, like we would do a parallel line, you can see that we have, in order to get the projection on the z-axis, we need to draw a parallel to the base in this case, and we end up at 1c. So this would be the c. It's exactly 1c. The projection, when we divide by c, that's going to be a 1, an integer, in other words. So u, v, and capital U, capital V, and capital W are 1, 1, and 1. And then we proceed on using those formulas, very simple math, to transform in a 4-axis coordinate frame, and we get these fractions, and 1 here, and we can see that we need to reduce the next step, reduce the fractions, so that means the least common multiple will be 3 in this case, and we end up, when we are multiplying with 3, we end up with a 1, 1, minus 2 here, and 3 there for the 1. So we drop the commas and we put them in the brackets, and the negative sign, it's a bar above the 2. And that's how we get the coordinate frame, the Miller-Bravais indices for this direction. And those are the 1, 1, 1, 2, minus 2, or 2 bar, and 3. I hope it helps. Please let me know otherwise in an email, and I also hope you have a beautiful day.